let me come back to the fundamental theorem of calculus part 1. Okay, when I explained this one, since I didn't show you like all the detailed proof of this one, like it is not easy to understand. Okay, but like since we know the fundamental theorem of calculus part 2, that we can use that idea for this problem. Okay, so we're gonna try find g prime. Okay, before then we're gonna use the fundamental theorem of calculus part 2 first. Okay, so what I'm gonna do is this. Okay, here we go. So if I say my function f of t is square root of t cubed plus 1, but even we do not know, but like let's assume there is the antiderivative of this function. Okay, and let capital F of t prime is equal to f of t. That means capital F is the antiderivative, right? Then I can rewrite this problem as like this way. It is equal to integral -1 to x f of t dt, right? So at this moment, let me apply the fundamental theorem of calculus part 2. Then with antiderivative of this function and plug in -1x, which is f of x minus f of -1. Now we are ready. Okay, I just like transform your given integral, definite integral, into this form. Okay, so now like as you can see in the problem, we have to find the derivative of this function. Okay, what is g prime? G prime x is the derivative of this whole thing, right? F of x minus f of -1. And then, okay, look at that. We're going to take the derivative of like first term and second term separately, right? Since we know, here we go, f prime, we define f prime is small f, right? So this one will be f of x. That's it, right? But what about this one? Capital F of -1 prime. Well, think about it. Even we do not know exactly, but capital F is a function, okay? When you plug in -1, it is not a function anymore, but it is function value, which is number, right? Number prime is equal to no matter what equal to 0, right? So your answer is f of x, which is f of t is this one. Then I'm going to replace your t with x, okay? Then it is square root of x cubed plus 1. This is another way to approach this problem with the fundamental theorems, the fundamental theorem of calculus part 2. Okay, for this problem, please watch the video for the fundamental theorem of calculus part 2 first, okay? Then you will understand what I'm going to do, okay? I'm not going to use part 1, but even this is the problem for part 1, but I'm going to explain this one with part 2. It might be much easier and understandable, okay? So here we go. So we're going to try to find g prime. That is target, okay? But before then, let me try to change this integral form a little bit different way with the fundamental theorem of calculus part 2, okay? Here we go. So what I'm going to do is, first of all, look at that. Let's say my function f of t is t squared over t squared plus 1, okay? But I don't want to ask you to find the antiderivative of this function, but let's assume there is. Is that okay? So let me define capital F of t as antiderivative, okay? You understand this notation, right? This notation means capital F is the antiderivative of function f, given function f, okay? Does it make sense? Then now, it is time to use the fundamental theorem of calculus part 2, right? Before then, let me replace your function with f of t notation, okay? So this one is equal to integral 1 to square root of x and f of t dt, okay? Then, by the fundamental theorem of calculus part 2, and this can be written by with antiderivative and big bar notation 1 and square root of x, right? Then what are you going to do? Plug in the right limit first, okay? It is f of x minus f of 1. There we go. So now I just change your definite integral form into this algebraical form, right? Now it is time to take the derivative, because the question asks you to find the derivative, right? So now it is time to do that, okay? We need g prime x, right? Which is the derivative with respect to x with this integral, or we can use this one instead, right? F of square root of x minus f of 1. Are you okay so far? We're going to take the derivative first term and second term separately, right? And first term, take the derivative, okay? But, oh, wait a minute. Look at that. Can you find this one? Capital F is outside function, or we can say it's Jacob function. And the square root of x is inside function, or we can say T-Schultz function. Is that okay? I'm talking about chainer, okay? Talking about chain, okay? So like to help you to understand this one, I will write here. We have to use the chainer, okay? Then what happened? Capital F prime, capital F prime, capital F prime is small ft, right? So that is equal to f of inside the function. Then whenever you write the inside function, then you have to multiply the inside function prime. What is that? Like, you know about this, right? It is 1 over 2 square root of x, okay? Does it make sense? Okay? And then what about second term? F of 1. Again, same thing, okay? Even we do not know about the exact form of capital F function, capital F, capital of x, but it is function that we plug in 1, which is number. Then now this is not the function anymore, but that is the function value, okay? Then function value, since the function value is number prime is equal to 0, right? So that's it. So this one is equal to f of x times 1 over 2 square root of x, right? Then f of x is here, right? T squared over t squared plus 1. Now we're going to plug in square root of x into there. That is squared times 1 over. So you can answer this problem x over, it is squared as well, right? X plus 1 times 1 over 2x, okay? Or you can simplify more, okay? But this is the way to take care the fundamental theorem of calculus part 1 problem with part 2, okay?